Good morning, my dear students. Today we are going to discuss Bernoulli and binomial distributions. So, the objectives of Bernoulli and binomial distributions are, after studying this unit, you will able to, first one is identify the situation where Bernoulli distribution and binomial distribution can be used. Define the probability mass function of the above two distributions, those are Bernoulli distribution and binomial distribution. The third objective of these distributions are identify the characteristic features of these distributions. And fourth one is study the various statistical measures like mean, variance, coefficients of skewness and kurtosis for the above distributions. That means, we are going to discuss above objectives of these two distributions like Bernoulli and binomial distributions. Now, we are going to discuss Bernoulli trial. What do you mean by Bernoulli trial? When a random experiment results in two and only two mutually exclusive outcomes, if the probability of results remain in the same in each trial when the experiment is repeated independently, such experiment is called Bernoulli trial. Bernoulli distribution. Who is introducing the Bernoulli distribution? So, this distribution was named after James Bernoulli in the year 1654 to 1705, who proposed it in his book The Arc Conjectuandi. When a fair coin is tossed, there are only two mutually exclusive and exhaustive outcomes. As you know, according to this probability, there are only two events may be occur. Those are exclusive and exhaustive events, which is denoted by head or tail, may be turn up. Getting generally, a head is considered as a success and getting a trial is considered as a failure. So, generally which failure and success. Failure is always represented by Q and success is always represented by P in terms of probability definitions. Generally, getting a head is considered as a success and getting a trial is considered as a failure. Since the coin is a fair, the probability of success P is equal to 1 by 2. You know what is the definition of probability. So, probability is defined as favorable number of cases by exhaustive number of cases. That is why our success getting of head is equal to 1 by 2 and probability of failure is represented by Q. Q is equal to 1 by 2. If the coin is not a fair coin, then the value of P and Q may not be equal to 1 by 2. So, however, the values of P, Q are such that P is always greater than or equal to 0. That means, P is non-negative and sum of these success plus failure, that is P plus Q is equal to 1. Tossing of the coin independently is a Bernoulli trial. Bernoulli trial. For example, when a fair dice is cast, one of the number turned up 1, 2, 3, 4, 5, 6. If getting 5 is considered as a success, it is indicated by A, then A complement stands for getting of one of the numbers other than 5, that those numbers are 1, 2, 3, 4 and 6. In this case, the probability of success P is equal to favorable number of cases by exhaustive number of cases. What is the favorable number of cases? Only one, that is getting of 5. So, total exhaustive number of cases are all possible outcomes. All possible outcomes of in this event is 1, 2, 3, 4, 5, totally 6. Therefore, your success P is equal to 1 by 6, while the probability of failure, which is denoted by Q, Q is equal to 1 minus P. 1 minus P is equal to 1 minus 1 by 6, that is equal to 5 by 6. Therefore, Q is equal to 5 by 6. Therefore, the probability of failure case is 5 by 6 in this example. Throwing of a die independently is a Bernoulli trial. So, already we discussed these are the comes under Bernoulli trials. Suppose an urn consists of B black balls and R red balls. If a ball is selected at a random from the urn, then it can be either a black ball or a red ball. If the ball that is selected is put back into the urn, then each trial of the probability getting a black ball is P is equal to success rate, P is equal to B by B plus R. That means favorable number of cases by exhaustive number of cases, while probability of getting a red ball is Q is equal to R by B plus R. Such a trial is also referred to as a Bernoulli trial. Okay. So, all the above cases, are you understand that things? So, now we are getting of success events or getting of failure events comes under Bernoulli trials. In a production process, an item that is produced may be considered as a conforming one when some quality characteristic lie within specified limits, or it might be non-conforming item when the quality characteristic lies outside the specific limits. If we denote that event that an event item is conforming one with A and by A complement, it is non-conforming item. The probability of these events remain constant, then it is a Bernoulli trials. So, all the above examples are you understand the Bernoulli, what you mean by Bernoulli trials. So, I hope you are understanding what you mean by Bernoulli trial. So, after Bernoulli trial, now we are going to define the what you mean by Bernoulli distribution, definition of Bernoulli distribution. So, Bernoulli distribution is comes under discrete type of distribution, as you know. Okay. So, now I am going to discuss and different properties of this particular distribution. So, now what is the definition of Bernoulli distribution? A discrete random variable x is said to have a Bernoulli distribution if it assumes only two possible values 0 and 1, and its probability mass function is given by probability of x is equal to capital X is equal to small x is equal to P of x is equal to P power x into Q power 1 minus x. X takes a values only 2, already I just mentioned the above condition, that conditions are x takes a values 0 and 1 only. So, already we know that P lies between 0 and 1, P plus Q is equal to 1. Other than these two conditions, the probability of that probability mass function is goes to 0. That probability mass function is goes to 0. So, therefore, what is the probability mass function of the Bernoulli distribution? P of x is equal to P power x into Q power 1 minus x. Otherwise when if the two conditions are not satisfied, fail, in that case that probability mass function is goes to 0. Those conditions are probability is always P is lies between 0 and 1, P plus Q is equal to 1. So, now one important note from this distribution, from the above definition it is clear that probability of x is equal to 0, that means that is probability of x is equal to 0 is equal to Q, and probability of x is equal to 1 it may be treated as a success, that is equal to P. Okay. This is very important thing. If it is x value takes a 0, then it becomes a failure case. If x takes a value 1, then it is a probability of success, that is represented by P. So, what are the properties of Bernoulli distributions? Now, we are going to discuss one by one. So, properties of Bernoulli distributions. So, as you know, Bernoulli distribution is a which type of distribution? It is a discrete distribution. So, that is why we are taking always we are taking our random variable in terms of discrete random variable only. If x is a Bernoulli variate, then its mean is equal to, in terms of mathematical expectation, we can write expectation of x is equal to 0 into Q plus 1 into P is equal to P. So, therefore, we know that we are identify the mean of the Bernoulli distribution is equal to P. Just to remember this mean, this is very important property of Bernoulli distribution. Now coming to second one is variance. So variance of the Bernoulli distribution is PQ. From these 2 points, mean and variance, we can remember one important note, that is, have you observed this mean value? Mean is equal to P and variance is equal to PQ. So we observe from these two properties, mean is always greater than variance is the characteristic feature of Bernoulli distribution. This distribution is having mean is greater than variance. You have to remember this property. What is the coefficient of skewness of this Bernoulli distribution? As you know, coefficient of skewness is represented by beta 1. Beta 1 is equal to mu 3 square by mu 2 whole to the power of 3. Already we are aware of coefficient of skewness values of this mu 3 whole square and mu 2 cube. That values is substitute in beta 1 formula, then we will get coefficient of skewness. Therefore, our coefficient of skewness beta 1 is equal to 1 minus 2p whole to the power of 2 divided by p of 1 minus p. This is the coefficient of skewness of the Bernoulli distribution. Okay. So now from this also we can make a one important note, that is, when p is equal to 1 by 2, then beta is goes to 0. So that distribution of x becomes a symmetric distribution. When this distribution goes to symmetric distribution, if p is equal to 1 by 2, the beta becomes 0, then this Bernoulli distribution becomes a symmetric distribution. So now one more important properties of Bernoulli distribution, that is moment generating function. Moment generating function. So moment generating function, how to identify, how to generate, how to define this moment generating function? If x follows a Bernoulli distribution, its moment generating function is mx of t is equal to expectation of e to the power of tx is equal to q into e to the power of t into 0 plus p into e to the power of t into 1. So we know that e to the power of 0 is equal to 1, therefore that expression becomes q plus p e to the power of t, which is the moment generating function of Bernoulli distribution. So Bernoulli distribution moment generating function is equal to what? Q plus p into e to the power of t is the moment generating function of Bernoulli distribution. So one more important properties of Bernoulli distribution is characteristic function of Bernoulli distribution. So how to define the characteristic function? The characteristic function of Bernoulli distribution is, if x follows Bernoulli variate, then its characteristic function is phi x of t is equal to expectation of e to the power of I t x is equal to q into e to the power of I t into 0 plus p into e to the power of I t. Just like earlier we discussed about moment generating function. Instead of t x we can write I t x. Just you replaced, instead of I t x, instead of t x you can replace it by I t x. Then you will get a characteristic function of Bernoulli distribution, that is q plus p into e to the power of I t. That is the characteristic function of Bernoulli distribution. Now we are going to second distribution, that is binomial distribution. Binomial distribution was proposed by James Bernoulli. It is an important theoretical distribution having wide application in social science and business and commerce. In statistical quality control, it is used for constructing control charts for fraction of defective units and number of defective units, which is represented by P and NP charts. We can use in statistical quality control point of view, you have to identify the defective units and number of defective units for by making use of these Bernoulli and binomial distributions. So now the defective, just like we use the chart P chart and NP charts. Now definition of binomial distribution. A discrete random variable x is said to follow a binomial distribution with parameters n and p if it assumes only non-negative integer values and its probability mass function is probability of x is equal to p of x ncx p power x into q power n minus x. X takes a values 0 to n, otherwise this function is goes to 0. So, p is always lies between 0 and 1, q is equal to 1 minus p. We know that total probability is equal to 1, sum of the probability is equal to 1, that means p plus q is equal to 1 always. So, these are the limits for this particular binomial distribution. So, the following experimental conditions are to be satisfied for using the binomial distribution. The first experimental condition is each trial results in two exhaustive and mutually exclusive outcomes generally termed as success and failure. The probability of success p is a constant for each trial. The number of trials n is finite. The trials are independent. The trials are independent. If x follows binomial distribution b of n comma b, then its first moment about origin is mu1 dash. That mu1 dash is provided to us mean of the distribution. So, mu1 dash is equal to expectation of x. Expectation of x is equal to summing over x is equal 0 to n x into ncx into p power x q power n minus x. What is this? This is the probability mass function of the binomial distribution. Now, we can expand this ncx, we can decreasing one term. In that case np is a constant term, taking outside, summing over x start with 1 to n in n minus 1 of n minus 1 into n minus 1 c of x minus 1 p to the power of x minus 1 into q power n minus x. After simplifying this summation, we will get n plus np of p plus q whole to the power of n minus 1, but we know that p plus q is equal to 1, p plus q is equal to 1, therefore, something power n is equal to 1. So, np into 1 is equal to np, therefore, the mean of the binomial distribution is np. So, mean of the binomial distribution is np. The second moment about the origin is mu2 dash, that is expectation of x square, summing over x is equal to 0 to n x square into its probability mass function, that is ncx p power x q to the power of n minus x. Now, we can decreasing two terms of that summation, n of n minus 1 into p square is taking outside, n minus 2 c of x minus 2 into p to the power of x minus 2 into q to the power of n minus x plus np. After simplifying this x summation, we will get n of n minus 1 into p square plus np. Therefore, now we would like to find the variance. Variance is equal to mu2 dash minus mu1 dash whole square, that is expectation of x square minus expectation of x. Okay. So, expectation of x whole square. So, now we can substitute mean. Mean of the binomial distribution is np, already you know, just you can substitute these two values. Therefore, our variance mu2 is equal to npq. Mean is equal to np and variance is equal to npq of the binomial distribution. Now, next properties of binomial distribution is coefficient of skewness. This is important because we can identify the nature of the distribution. For a binomial distribution, x follows b of n comma p. The third moment about the origin is coefficient of skewness is equal to beta 1 is equal to mu 3 square by mu 2 whole to the power of 3. Already we know how to generate this mu 3 and mu 2 and mu 3 values. So, substitute these values in beta function. So, beta 1 is equal to skewness of the distribution. So, that is beta 1 is equal to q minus p whole to the power of 2 divided by npq. Simply this we can write here 1 minus 2p whole to the power of 2 divided by npq. Now, we should find the gamma 1 value, that is kurtosis, that is equal to under root of beta 1 is equal to 1 minus 2p divided by under root of npq. This is the coefficient of skewness as well as kurtosis of the binomial distribution. So, now we should find the total values. Therefore, beta 4 is also required. Beta 4 formula is equal to mu 4 by mu 2 square, that is equal to 3 plus 1 minus 6 into p q divided by n p q. Gamma 2 is equal to beta 4 minus 3, that is 1 minus 6 into p q divided by n p q. Now, from this we can conclude the some few properties of the few relations of the binomial distributions. That is, when the number of independent trials as n tends to infinity, and beta 1 is goes to 0 and beta 2 is tends to 3, in this case binomial distribution tends to a normal distribution. This is known as a limiting case of the binomial distribution. So, binomial distribution tends to the normal distribution using certain conditions, that is n tends to infinity and beta goes to 0 and beta 2 is tends to 3. Now, moment generating function of the binomial distribution. So, this is already we discussed moment generating function in Bernoulli distribution. Now we are discussing the moment generating function of the binomial distribution also. Here also, whenever we are talking about moment generating function of the binomial distribution, we will consider the mass function of the binomial distribution. What is the mass function of the binomial distribution? Probability of x is equal to capital X is equal to small x is equal to p of x is equal to NCx into p power x into q power n minus x. If x follows b of n comma p, then its moment generating function is. So, moment generating function is represented by mx of t. Mx of t is equal to expectation of e to the power of tx. So, because we use the summation, that means our distribution is discrete distribution, that is why we use the symbol summation here. Summation x takes a values 0 to n e to the power of tx into ncx into p power x into q power n minus x. Now, we can simplify this term e to the power of tx into ncx into p power x into q power n minus x. Ncx is taking outside. Now, here e power tx and p power x bases are, so x is a common in both terms. Now, what I am doing here, I am taking the e power tx into p, treated as a one term, I can write whole to the power of x into q to the power of n minus x. After expanding this summation, we will get one expansion form, that is q plus p into e to the power of t whole to the power of n, which is the required moment generating function of the binomial distribution. So, what is that? mxt is equal to q plus p into e to the power of t whole to the power of n, which is the required binomial distribution moment generating function. If you do the differentiation with respect to t and put d is equal to 0, we will get a required mean variance of the distributions. Okay, now that is the main important properties of the binomial distribution. Now, coming to one more important property is characteristic function of a binomial distribution. If x follows b of n comma p, its characteristic function is phi x t is equal to e to the power of I t x is equal to summing over x is equal to 0 to n s power x into n c x p power x q power n minus x is equal to x is equal to 0 to n c x, then here s to the power of x is there, p power x is there, powers are equal. Now, we can take right to s into p whole to the power of x I can write, then I will get new term, that is p s whole to the power of x into q to the power of n minus x. After expansion of this summation, we will get one new form, that is q plus ps whole to the power of n. This is the probability generating function of binomial distribution. Next one is additive property of binomial distribution. This is important property of binomial distribution, that is additive property. Suppose x and y are two independent random variables with x follows binomial distribution of n1 comma p, y follows b of n2 comma p, then additive means sum, then x plus y as a binomial distribution with parameters n1 plus n2 and p. The difference of two independent binomial variates is not a binomial variate. Only one additive property is satisfied. That additive property of binomial distribution is x follows binomial distribution, y follows binomial distribution, then we can say x plus y is also follows binomial distribution with parameters n1 plus n2 comma p. So, now I am going to conclude with the summary points of these particular distributions. So, we will discuss one by one. Just recall what are the things we are discussed already. I am going to brief about these two distributions, like first one is Bernoulli distribution and second one is binomial distribution. When a trial results in two and only two mutually exclusive and exhaustive cases, say success and failure with constant probability, such a trial is called a Bernoulli. Second one is a discrete random variable takes only two possible values with constant probability, is that called a Bernoulli variate. Third key point of in this lesson, for a Bernoulli distribution with probability p for success, mean is equal to p and variance is equal to pq. Fourth important point is mean is greater than variance is the characteristic feature of Bernoulli distribution. Only one distribution, this distribution is having mean is greater than variance while comparing these two values. Who is introducing this Bernoulli distribution? That is the fifth category important point, that is James Bernoulli was proposed by this distribution named as binomial distribution. If a Bernoulli experiment is repeated independently for n times, then the number of success observed in those trials as binomial distribution. In a binomial distribution, there are two parameters n and p. So, mean of the binomial distribution is equal to np and variance of the binomial distribution is equal to npq. Now, in this distribution is also mean is greater than variance. Mean is greater than variance is the characteristic properties of binomial distribution. So, now Bernoulli distribution is also mean is greater than variance, and in binomial distribution also mean is greater than variance. So, with this I can conclude that now these two important distributions comes under discrete type of distributions. So, already we discussed all the remaining properties, just recall your previous property, just I will conclude this session today. Okay. Thank you.